Hey guys, today I'm going to continue teaching you how to solve systems by graphing. This is part 2, so don't watch this till you've watched part 1. By the end of this lesson, you'll be able to identify how many solutions a system has, one, none, or infinitely many. And remember, today it's just doing that by graphing. So go ahead and get your binder, turn to the math section, and get ready to take some notes. So let's jump right in, and you might remember some of this from the introduction that we talked about solving systems by graphing, where there's 3 different types of solutions we'll see. So remember, just to review, a solution to a system of equations is just the point where the two lines intersect. So there's some other possibilities we might see here. Would it be possible to have a system of equations with no solution? We know that is true, yes. So like I said, you saw in the introduction to this, if the lines don't ever intersect, they would have no solution. Remember, a solution is where they cross. So if the lines are parallel to each other, they will never cross. So there can never be a solution to that system. The other option you might see is that it's possible for a system of equations to have infinitely many solutions. And that's whenever they are the same line. Sometimes it's written in different formats or they might look different, but if the lines are right on top of each other, if they're the same line, they share every point. Every point is a solution. Therefore, they'd have infinitely many solutions to this system. So there's 3 options. Let's just review that real quick. The first one we've been comfortable with, when there's one solution. That's when you have 2 different lines intersecting at one point. That one point will be the solution to the system. If they have different slopes, there'll always be one solution to the system. That's one way to know for sure without even having to graph it. If you see 2 lines that have different slopes, there will be one solution to the system. The other option will be when the lines are parallel. There will be no solution. Because the lines will never touch, again, there will be no solution. There can be no point where they intersect. So a way to remember that is same slope, but different y-intercept, like these 2 lines are here. They start at a different y point, but they go the same direction. They have the same slope. They're increasing at the same rate. So in this case, there is no solution. They're going to go on and on forever in the same direction. They're never, ever going to cross. The third type of thing you might see with systems is that there might be infinitely many solutions. That's when it looks like there's only one line here. This is not one line because it's a system. System means that there's 2 lines. But what's really happening here is it's almost like you have a blue line, and then on top of it, you have this red line. So you can't even see which one's which. That's whenever you would have infinitely many solutions. It means they're touching at every single point. So every point that you have on this graph would be a solution for them. So if they have the same slope and the same y-intercept, you're going to have infinitely many solutions. Some people get confused between these two, where how do you know if it's no solution or infinitely many solutions? If there's no solution, they're never ever touching. They have the same slope, and you can see there's 2 different lines here. But if there's infinitely many solutions, it looks like it's just one line. They'll have the same y-intercept, the same starting point, and the same slope. So there are infinitely many solutions. So I will walk you through 2 examples here, and then you can decide how many solutions each of these systems of equations will have. So starting here on the left, on number 1, I've got 2 equations. The deal is with this one, and this is where it gets a little harder. Only one of them is written in slope intercept form. Only one of them is written where it's y equals. So I need to rewrite the second one into slope intercept form before I can even get started. Now, if you have some sort of graphing software or a graphing calculator that lets you type in y and x on the same side, then you can go ahead and type this in and graph it. However, if you don't, then you need to convert the second equation into slope intercept form before you can get started. So we'll do that in just a second. Let's go ahead and start with color coding these 2 lines. I'll use purple and orange. Purple line, like I said, I can graph that right now because that is in slope intercept form. So I'm going to begin at the B. That's our -3 or -3. That's our very first point, and it's on the y line. The slope is next to the x, and that tells me how to move. It's up 2 over 1. So I'm going to continue going up 2 over 1 and plot each point on my graph. From point to point, I'm going up 2 over 1. That's the pattern that this graph follows. So the line will look something like this. Now, before we graph the orange line, like I said, we need to make it y equals. We need to put it in slope intercept form. So I'm going to go to a new page, and I'm going to translate this into slope intercept form. Again, this is in standard form because y and x are on the same side. It's harder to graph when it's in standard form. I personally want it in slope intercept form. That's whenever the y is all by itself. I want it to be a y equals. So I'm going to get the y by itself by solving this equation for y. So to do that, I'm going to use my inverse operations. I need to get rid of a 4x from the left because all I want on the left is the y. So I'm going to move that 4x to the other side. Now all I'm left with on the left side is 2y equals 2 plus 4x. Remember, it's not in slope intercept form until the y is by itself. I need a y equals. That's what makes something slope intercept form. So I need to get rid of this times 2, and I'm going to do that by dividing by 2. So now all that's left on the left is a y equals. But on the right, I need to divide each one of these by 2. So 2 divided by 2 is 1. And then 4 divided by 2 is 2. So y equals 1 plus 2x is the same equation as what we started with. This one is written in slope intercept form because it's y equals. So that is more helpful to me. I'm going to cross that out, and I'm going to write y equals 2x plus 1. And remember, I just crossed out this equation in standard form and replaced it with the same equation written in slope intercept form. Slope intercept form is more helpful to me because I can graph by using what I know about B and M. So I'm going to begin at 1. At 1 here is my first point. Let's graph it in orange. And then I'm going to go up and over by 2. So up 1 over 2, up 1 over 2, up 1 over 2. And then the same way I'm going to go backwards. Down 2 over 1, down 2 over 1, down 2 over 1, and so on. My line will look something like this. If you notice, you can visually see that these two lines are parallel. And if you look back at the equations of the lines, once I put them both into slope intercept form, I can see they both have the same slope of 2, but a different y-intercept. So no solution. Same slope, different y-intercept. They're parallel. They're never going to cross. This is an example where there is no solution, or the solution does not exist. So you can put no solution or D in E. Does not exist. You can try number 2 by yourself, or you can let me walk you through it. I'm going to do the same thing I just did with the one on the left, except this time you're going to see another thing in standard form. You're going to need to convert that into slope intercept form before you begin. So I'll start by making sure that I have 2 colors for these 2 lines. The top one I'll make purple, the bottom one I'll make orange, and I'm going to graph the purple line, starting with the y-intercept of 4. I always want to begin with the B. Now it's going down 1 over 2. I know that because it's got a negative slope, and it's always rise over run. So it's up and down first, then it's left to right. So down 1 over 2, down 1 over 2. And I'm just going to keep plotting points, as many as I can, so I can get the more accurate picture of my line. It should look something like this. Remember, it's linear, so it should be as close as it can get to a straight line. Now I'm going to convert this equation into slope-intercept form. Remember, if you have some sort of Desmos or a graphing calculator that can handle this, you can just type that in, but I'm going to put it in slope-intercept form algebraically. And I'm going to do that by making sure that it's y equals all by itself on one side. So I'm going to do inverse operations to get that y by itself. So I'm going to get rid of that x by subtracting x. It's a plus x, so I need to minus x. So I'm left with 2y equals 8 minus x. Then I'm going to do the opposite of times 2. I'm going to do it to both sides. So now I'm left with y equals 8 divided by 2 is 4 minus 1/2 x. And I know that because this is a 1 next to that x. So minus 1/2 x or minus 1x over 2 is the same thing. So my equation is y equals 4 minus 1/2 x. I can rearrange that to be y equals negative 1/2 x plus 4. I rearrange it just because I want it to be mx plus b. That's just easier for me to look at. And the commutative property tells me I can move this around as long as I keep the same sign next to the same number. So that's why I did that. I'm going to cross out this equation and write y equals negative 1/2 x plus 4. If you notice already, this is the same equation as this one. This was just written in a different form. So when I graph this orange line, I'm going to start at 4 and go down 1 over 1. So I'm going to do the same thing I just did with the last one. And if you notice, I'm plotting the same points. Those points are all going to fall on this purple line. So this orange line is the exact same as the purple line. This is an example where you would have 2 equations that have infinitely many solutions because they have the same slope and the same y-intercept. These are the same line. So infinitely many solutions would be your answer to this question. And that's it. That's all you have to do for that. All right, guys, that's it. If you made it to the end of this video, please comment what your favorite meal of the day is. Today, we learned about part 2 of solving systems by graphing. This is the last part, so this was the hardest part. So today, now you should be able to identify how many solutions the system has, either 1, none, or infinitely many. And that was a little more difficult because we saw systems of equations written in standard form. So if you need more help with that, please let me know. So now you should go back to the calendar and click any other assignments you have left for the day. Again, please let me know if you have any questions. Bye.